Hello, good people. This video is on section 5.1, Laplace transforms. So we want to look at the Laplace of t to the n. Okay, now I'm kind of piggybacking. Well, let's just go through it. So this, by definition, is the integral from 0 to infinity of. This is the integral from 0 to infinity of e to the negative st t to the n dt. And if I do integration by parts, I let u equal t to the n, dv equals e to the negative st, du equals n to the n minus 1, and v equals negative 1 over s e to the st. So therefore, this is equal to, this is the integral of, so we know that the integral of u dv is equal to uv minus the integral of v du. So that's our uv, that's minus the integral of v du. And notice this is really just 0 over 0, because if t equals 0, then I just have 0. And if t equals infinity, well, you see, the e gets bigger faster than the t to the n, and the limit winds up being 0. You can prove it with L'Hopital's ruler any way you want. Anyway, so this whole thing is just 0. Let's exit out. And here we have n over s times. Now I'm basically borrowing a technique that was done in class by he who shall not be named. But this over here is just the Laplace of t to the n minus 1. So the Laplace of t to the n is equal to n over s times the Laplace of t to the n minus 1. Well, following that logic, that means the Laplace of t to the n is going to be n over s times n minus 1 over s times the Laplace of t to the n minus 2. And then following that, to its conclusion, you get n over s times n minus 1 over s times n minus 2 over s, times 3 over s times 2 over s times 1 over s times the Laplace of t to the 0. But we know that the Laplace of t to the 0 is 1 over s. We did that in class. So therefore, this whole thing winds up being, if you count up all the s's, there are from here to here is n, but there's another s over there, so that's n plus 1 s's, and on top you really wind up just having n factorial. So the final bottom line is that the Laplace of t to the nth power is equal to n factorial over s to the n plus 1 power. And again, we're still working that restriction that s has to be positive. And this is how we do that.